Hi, I'm Gretchen and I work on Core Bluetooth. Today, I'm excited to introduce a way to find nearby Bluetooth accessories using channel sounding. First, I will give you some ideas for how you could use channel sounding and how it works. Then I will explain how to implement it in your app using Core Bluetooth to get distance, or with nearby interaction to get distance and direction to your accessory. Next, I will give you some tips for building hardware that supports channel sounding. And I will end with some next steps. Let's start with an overview. Imagine I'm hosting a party. I'm cooking inside using my oven, and I have a smoker going in the backyard. I have Bluetooth thermometers in both places to help me cook everything perfectly. I get a notification that one of my thermometers has reached the temperature I set. When I open the app, it says the probe is 8 meters to my right. That must be the smoker. With channel sounding, I won't mix up my temperature probes. I can measure distance to each one. There are a couple ways to measure distance and direction to third-party accessories on iOS. For the best accuracy, you can add an ultra-wideband chipset to your accessory and use the Nearby Interaction framework in your app. For more information on this, watch the video Explore Nearby Interaction with Third-Party Accessories. But if your accessory only has a Bluetooth chipset, then Bluetooth channel sounding is your best option. You might have used RSSI in the past to estimate distance, but with channel sounding, you can actually measure distance. We encourage you to try channel sounding where your app could benefit from better accuracy. So, how exactly does channel sounding work? Let's say we have an iPhone that is paired and connected to a Bluetooth accessory. In this scenario, the iPhone is called an initiator, and the accessory is called a reflector. The iPhone sends a signal, or tone, to the accessory, and the accessory reflects that tone back. The iPhone measures how the signal changes in transit from one side to the other and back. By repeating this process across the channels of the 2.4 GHz band, the iPhone observes the rate of change in these reflected tones from one channel to the next, and uses that to estimate the distance between the initiator and reflector. This process of measuring distance is called a procedure. So, how do you perform channel sounding in your app? If you just need distance, you can use Core Bluetooth. Before you begin, you'll want to ensure your accessory is paired and set up using Accessory Setup Kit and connected through Core Bluetooth. You can refer to the documentation for more on how this is done. Now, let's look at the code to measure distances. First, check that channel sounding is supported on the local iOS device using CB Central Manager's Supports Features method. Once you have a connected CB peripheral, call Start Channel Sounding Session on the CB peripheral object. iOS will repeatedly perform channel sounding procedures. When each procedure is completed, the delegate method, peripheral did receive results, will be called with the measured distance in meters. When you are ready to complete your channel sounding session, call Cancel Channel Sounding Session. When the session ends, the delegate method, peripheral did complete channel sounding session, will be called. Next, I'll tell you how to use nearby interaction to measure distance and direction. Again, ensure your accessory has been paired and set up through Accessory Setup Kit and connected by a Core Bluetooth. Before creating a channel sounding session, check whether the local iOS device supports it with the Supports Bluetooth Channel Sounding method. Then create a configuration object, passing in the peripheral identifier from core Bluetooth as the Bluetooth channel sounding identifier. In order to get direction, camera assistance is required. Be sure to enable this if you need it. Finally, create your NI session, set the delegate, and run it with the new accessory configuration you just created. If your app knows whether the accessory is moving or stationary, you can tell nearby interaction, and it will use that information to produce better direction estimates. Call Update Motion State on your session with your accessory object's discovery token. For example, if your accessory is a mounted tag on a wall, pass stationary. If it's attached to a moving object, pass moving. The delegate callback is identical to what you'd get with UWB. You will receive NI nearby object updates with distance and direction. Both the distance and the direction results benefit from the fusion of raw Bluetooth channel sounding measurements and camera inputs. Remember that both distance and direction are optional. Distance may be nil if the channel sounding measurement failed. iOS automatically filters outliers and smooths your results for a better user experience. In iOS 27, use channel sounding when your app is in the foreground. When your app moves to the background, your channel sounding session will be paused. Also be aware that iOS may reduce the frequency of channel sounding measurements if other Bluetooth or Wi-Fi activity increases. Channel sounding is available on iPhones with the N1 chip. Now I will explain how to make your accessories work well with channel sounding on iOS. Your accessory must support Bluetooth 6.3, and the inline PCT feature is required. iOS uses phase-based ranging, so your chipset must also support Mode 0 and Mode 2 as defined by the Bluetooth spec. TFCS is the interspace timing between tones. Make sure your accessory supports TFCS of at least 100 microseconds. All right, you've heard all about channel sounding, but what's next? Try out the APIs with a compatible accessory. Imagine how measuring distance would improve how people interact with your app. Ask your questions on the developer forums and send us feedback using Feedback Assistant. Thank you.